What's up, math scholars? Thanks for joining me on day 2. We're going over the second half of the study guide today, number 7 through 12. So thanks for joining me. All right, we are on 7. Hopefully you have your unit circle still available to you. We are still solving, and we're still solving in the interval from 0 to 2 pi. So just keep that in mind. We're only going to look on that first trip around the unit circle. Let's start this first one off by subtracting 2 over to the other side. Don't lose your puppy. That means don't lose that negative sign. It's negative radical 3 cosecant x equals negative 2. At this point, we can divide over that negative radical 3 over to the other side. And that gives us cosecant x equals positive 2 over radical 3. Now that might seem strange to you because you're like, positive 2 over radical 3? I've never seen that number before. Well, it's because this is cosecant. You really have to think back to the meaning of cosecant and maybe even look at your identity sheet for what does cosecant actually mean. Cosecant is the reciprocal of sine. So what we can actually do is just flip both sides. If you flip cosecant, you're going to have sine. And if you flip 2 radical 3, you're going to have radical 3 over 2. Isn't that cool? So now it's unit circle time. Sing your little song. It's unit circle time. It's unit circle time. We're looking for all y values on our unit circle of radical 3 over 2. So I'm seeing 1 at 60 degrees, or pi over 3. And then 1 over at 120, or 2 pi over 3. So 2 answers. Alright, we are now under number 8. We need to find a new slip of paper in our notebook. This slip we taped in our notebook in section 10.6. Sum and difference formulas. So we're using the tangent sum and difference formula, but our first job will definitely just be to think of 2 numbers that would add or subtract to 255. Now, you can pick whatever 2 numbers you think of. It doesn't matter if they add or subtract to 255, and you'll end up getting the same answer as I will. I'm picking 120 and 135. Alright, so I'm looking at my sum and difference formula paper, and I'm going to want to use the one with the sum of a tangent. So it is tangent A plus tangent B over 1 minus tan A, tan B. Now you have to think of what am I going to have my A be, and what am I going to have my B be. A in this scenario would be a 120, and B would be a 135. So I'm going to go ahead now and put a 120 in everywhere I have an A written, and put a 135 in everywhere I have a B written. Okay. So it'll be tan 120 plus tan 135 over 1 minus tan 120 times tan 135. Now, before we can simplify that down any, we're going to have to do a little bit of grunt work. We're going to have to figure out what tan 120 is and what tan 135 is. So maybe over here I can try to squeeze that work in. Tangent 120. You would want to look at your unit circle at the 120 and grab the y value. So the y value is radical 3 over 2. And then you'd want to divide it by the x value. And the x value is negative 1/2. Now that would simplify down. These 2's would cancel out. It would simplify down to negative radical 3. So that's going to be our first piece of the puzzle. Everywhere we see a tan 120, we'll end up replacing with a negative radical 3. Let's do the same exact thing for 135. I need some workspace. To do tangent at 135, you'll grab your y value, which is radical 2 over 2. You'll grab your x value, which is negative radical 2 over 2. And then you'll simplify. Now it's the same exact number on the top and bottom minus that whole negative sign there. So tangent of 135 is negative 1. Again, if I get going too fast, feel free to just ask Mrs. Benson to hit pause or rewind and give you some time to look at things. And feel free to ask her questions. She is more than qualified to answer any Algebra 2 question you might have for her today. we're over here, every place you see a tan 120, you're going to replace it with a negative radical 3. Everywhere you see a tan 135, you're going to replace it with a negative 1. And then we're going to simplify this to the best of our ability. On the bottom, I'll replace that tan 120 with a negative radical 3. And I'll replace that tan 135 with a negative 1. I went ahead and put that in parentheses because product multiplication has to happen before subtraction with the order of operations. So it looks like the top really won't simplify down at all. It'll be a negative radical 3 plus negative 1. The bottom, those two negatives could become a positive. So it'll be a 1 plus radical 3. And that's about all we can do on this problem. I missed a minus. I was just stepping back and checking. I did miss a minus right here. These two became a positive, these two negatives, but then that minus up front still existed. So I lost my puppy and I apologize. So hopefully you weren't using 10. Okay, that looks much better. It matches my answer key. All right, we're moving on to number 9. We're doing a cosine 15. Again, 15 is not on our unit circle, but we can think of two numbers that are on our unit circle in that might have a sum or a difference of 15. So it's not hard to come up with the two numbers in this case. I'll give you a second to try to come up with them on your own. Find two numbers on your unit circle that either add or subtract to 15. And I went with 60 minus 45. And 60 minus 45 is 15. So that means I'm going to be using, on my sum and difference formula sheet, my cosine difference formula. So go ahead and jot that down off my sheet. Cosine A, cosine B, plus, and that's surprising, but it is opposite sign, sine A, sine B. So again, if you lost this sheet, it should be taped into your notebook in section 10.6. All right, we are going to need to determine what our A and B values are going to be in this scenario. So go ahead and think about what you're going to use. It is 60 for A and 45 for B. So everywhere you see an A, go with 60. Everywhere you see a B, go with 45. Alrighty, everybody, it's everyone's favorite time of day, unit circle time. So cosine 60, what we got? What's our x value at 60? 1/2. Cosine 45, that would be your x value at 45, radical 2/2. Sine 60, that's your y value at 60 degrees, radical 3/2. And then sine at 45, your y value at 45. At this point, you simplify this down to the best of your ability, and then you're done. So my first two, when I multiply them, I get radical 2/4. My second two, when I multiply them, I get radical 6/4. And then this is an adding problem, and we do have like denominators, like denominators, so we can go ahead, common denominators, I couldn't think of the word, common denominators. We can go ahead and add them up and have our final answer of radical 2 plus radical 6/4. Now you do know you can check your work. If you would just type in cosine 15, see what that decimal value is. You could also type in the radical 2 plus radical 6/4. You would need parentheses around the top, but it should be giving you that same decimal value. Make sure your mode is in degrees if you're going to type this type of problem in. Number 10, use the sum and difference formula to simplify down cosine x minus pi/2. So let's look at our sum and difference sheet and figure out what formula we'll be using. It should be the cosine A minus B formula. That's under the difference formulas. It's going to be cosine A, cosine B, and then sine A, sine B. What do you think we'll be using for our A and our B values? X for A and pi over 2 for b. And I know when we were learning this lesson, there were some questions. Do we want to use pi over 2 for b? Or do we want to use a negative pi over 2 for b? We're always going to have our a and b be positive numbers, and we're just going to let the formula take care of the whole minus situation, okay? All right. Everywhere you see an a, stick an x in. Everywhere you see a b, stick a pi over 2 in. So cosine x, cosine pi over 2, sine of x, sine of pi over 2. It's unit circle time. So you can't really look up cosine x, but you can definitely look up cosine pi over 2 on your unit circle. So cosine at 90 degrees is definitely 0. And then same with sine x, leave it as sine x, but go ahead and figure out what sine of pi over 2 is. Sine at 90 degrees is 1. So now you kind of think about how would this long expression simplify down? Well, anything times 0 is going to be 0. So this whole entire first term is just going to be 0. And so my final answer just would be 1 times sine of x, or sine x. It's kind of nice how that all just simplifies down to sine x. All right, we're on number 11, and we're using double angle formulas now. That's the third and final sheet of paper we taped into our notebooks. We should be looking in section 10.7 for our double angle formulas. Let's talk about what our goal is here. Having a goal in mind is important. Our goal is finding sine 2a. We'll definitely need a double angle formula to help us do that. So let's look at our double angle formula for sine 2a. Sine 2a is equivalent to 2 sine a cosine a. Now it is awesome they provide us with cosine a. Cosine a is just 1/2. But we don't know sine a, so that's something we're going to have to solve for ourselves, okay? Now anytime you're given cosine and you need sine, or vice versa, your best bet is just that Pythagorean identity, that really famous one we've been using a lot this chapter. Sine squared a plus cosine squared a equals 1. That's off that sheet on 10.3. You should have it memorized by now, to be honest. We're using it so much. So we're solving for sine, given that cosine a is 1/2. Now before we get any further, let's talk about where angle A actually lives, what quadrant angle A lives in. So let's draw our little circle. They do give us this information at the top that A lives between 0 and pi over 2. That's simple. That's quadrant 1. And anything in quadrant 1 is going to be positive. Cosine's going to be positive, sine's going to be positive. Everybody's positive who lives in quadrant 1. So just keep that in mind as we're solving. A is going to be positive. Sine A is going to be positive. So I'll go ahead now and square my 1/2. That'll be 1 over 4. At this point, we subtract that 1/4 to the other side. You can do that in your head. If you need to calculate or go for it, but 1 minus 1/4 is 3/4, of course. And finish it with the square root. Now, normally when we square root, we put that plus minus sign out front, but we discussed that sine A will be positive because of the quadrant 1 that we're living in. The square root of 3 is radical 3. The square root of 4 is 2. So that's your sine value. All right, I'll let you catch up a second. Yeah. So think back to what our goal on the problem was. Our goal on the problem is written at the top. We needed to figure out what sine 2a is. And we needed to perform 2 sine a cosine a. So we're just going to substitute some numbers in. Sine a, we figured out to be radical 3 over 2. Cosine a, they gave to us, it was 1/2. And then we just simplified this down. This 2 and this 2 cancel out. And then my final answer is just radical 3 over 2. Awesome. Alrighty, we made it. Number 12. Use double angle formulas to show the value of cosine 300. Must show all work. And you know why I'm saying must show all work, right? because you could just look at the unit circle and get your cosine of 300 right off the bat. In fact, I'll do that now. It's 1/2. But we're basically proving that the double angle formula works the way it should, okay? It's almost like you're verifying that the formula works. All right. So, first of all, let's talk about what angle we would double to get 300. You would double the angle 150 to get 300. So in that case, we're going to be letting our A value be 150. Now, cosine is unique. If you would look at the cosine double angle formulas on your sheet, you actually have 3 choices. 1 minus 2 sine squared A, 2 cosine squared A minus 1, or cosine squared A minus sine squared A. And it's totally up to you which one you use. Let's just use the first one since it's at the top. 1 minus 2 sine squared of A. So, in this case, we're just going to stick a 150 in everywhere we see an A. 1 minus 2 sine squared 150. I kind of awkwardly put my formula underneath my work, so I'm going to kind of flop that in a second. Okay. Give me a second. I moved it up out of my way so I have some space. We are going to go ahead and next up, just figure out what sine of 150 is. That number will end up getting squared because it is sine squared 150. So look at your unit circle at 150. What's the y value? It's a 1/2. So that 1/2 will be squared. We just got to simplify this down. If you want to type it in a calculator right at this point, you could. Nobody's going to stop you. If you want to work it out by hand, that's awesome too. So 1/2 squared is 1/4. Negative 2 times 1/4 is negative 1/2. And then minus 1 minus 1/2 is 1/2, which we had discussed earlier. We knew was the answer. So that proved the formula worked. Hey, thanks for joining me on my video. We did pretty good, 17 minutes. Please ask Mrs. Benson any questions you still have on the study guide. And the rest of the time, you're just going to be working on study guide number 2. It's up to her how she has you guys do it, whether she has you working alone or in group. She'll make that decision. And feel free to ask for any questions you have. It is not homework, so there is no homework tonight. But I will be back tomorrow to answer any questions, and we'll be playing some sort of board buddies game or something like that to further prepare for Friday's quiz. All right, have a good day.